Yes, on number 11, a 3-kilogram mud ball has perfectly inelastic collision with a second mud ball that is initially at rest. The composite system moves with a speed equal to 1/3 of the original speed of the 3-kilogram ball. What is the mass of the second mud ball? This is a challenge question. I put it on here on purpose. So, I've got some masses, and I've got the word speed, and I know one of the speeds is 1/3, or the second mud ball has a speed 1/3 of the original mud ball. What law do you think this applies to? Newton's is not a law. Law of conservation of momentum. If I've got a mass and I've got a velocity, I've got momentum. So, it's inelastic. So for number 6, or number 11, sorry. The answer is 6. Tell me, what's the equation I use for inelastic collision, conservation, and momentum?
F2 equals mv.
That's impulse momentum, you're close. Law of conservation of momentum states that momentum before is going to equal the momentum after. Inelastic collision means that the masses get stuck together. So back table, what do you think I do? That back table. Go ahead. But go ahead, try.
Would it be MVI 1 plus MVI 2 equals MVI 1?
You are so close. You are so close. In an inelastic collision, what happens to the two masses? They stick together, right? So since they stick together, m1 plus m2, and there's your final velocity. And 1, there's 2. Okay, I write that down if you don't have that, and you can get that out of the simulation or this lab. This is for an inelastic collision. So, they told us that the first mud ball was 3.00 kilograms, and that's mass 1. They didn't tell us the speed. Mass of the second ball is what we're trying to find. And I know that the composite system moves with a speed equal to 1/3 of the original speed. And we know that first ball has no velocity. The second mud ball is stationary. So then on this side here, they told us that the velocity is 1/3 of what it was when it started. So watch how I'm going to write this here. I'm going to say this is now equal to 1/3 of VI, and I can just call it VI because I have no initial velocity for the second. Process that for a second and see if it makes sense.
Wait, why did you put 1/3 VI?
So this problem states that the composite system means the two put together, moves at a speed equal to 1/3 the original speed. That's why I put the 1/3 out in front. Yeah, and that's why there's only one velocity here. That's exactly why there's only one velocity. And that new velocity, that new final velocity, is 1/3 the initial velocity. So really, I only have a couple of things to find. This cancels out. I've got 3.00 minus VI equals, and I'm going to distribute this. I gotta close my parentheses. And then what I can go ahead and do, I've got a VI here, is can I subtract VI from both sides? Or 1.00 VI from both sides? What can cancel out at that point? What's the same on both sides? Mm-hmm. And what's my last step? And I'll end up with 6.00 kilograms equals M2. So the secret with this one is just realizing that the final velocity is 1/3 of the initial one, and then just trust yourself to do the algebra. Just trust yourself to do the algebra, and you'll see that initial velocities eventually cancel out, and leaving you with your mass. The trick is how to set them up, and then once they're set up correctly, the algebra just goes with it.